lightning in the funnel, around the funnel. Up the top of the hill, we're going to try and shoot some more photos. Should have a little bit more contrast behind it. You ever forget what highway we're on? I don't remember. I think we're on Highway 270 going eastbound.
Hurricanes are large and intense tropical storms with winds of 74 miles per hour or greater. Hurricanes form over the warm waters of the northern Atlantic and eastern North Pacific Oceans. In the western North Pacific, similar storms are referred to as typhoons. Storms which form over the Indian Ocean, which often devastate India and Southeast Asia, are called cyclones. Hurricanes and typhoons in the northern hemisphere rotate in a counterclockwise manner. This is due to the rotation of the Earth, or what is known as the Coriolis effect. Hurricane season lasts from June through November, with August and September being the peak months. Hurricanes form over warm tropical waters in combination with a number of favorable wind patterns. During the hurricane season, there are an average of 100 tropical disturbances over the Atlantic Ocean. When the winds in these storms are less than 39 miles per hour, they are called tropical depressions. Of these 100 storms, around 10 will become tropical storms when their winds increase to 39 miles per hour. On average, 6 of these tropical storms will reach hurricane force when the storm winds exceed 74 miles per hour. 2 hurricanes will usually strike the U.S. coastline each year. It should be noted that these figures are averages, and actual numbers can vary greatly from year to year. Hurricanes which make landfall can be very destructive and deadly. Sustained winds in a hurricane can reach over 155 miles per hour, with gusts near 200 miles per hour. The storm surge can produce tidal waves of 25 feet or more, and this is why drowning is the greatest cause of hurricane deaths. The death toll from hurricanes can be unbelievable. In 1900, 6,000 people lost their lives when a hurricane smashed into Galveston, Texas. Cyclones can be even more devastating. In 1970, over 300,000 lives were lost when a powerful cyclone and storm surge hit Bangladesh. Hurricanes are rated by the Saffir-Simpson damage potential scale as follows. Category 1 hurricanes have winds of 74 to 95 miles per hour and a storm surge of 4 to 5 feet. There is some damage, mainly to trees and unanchored mobile homes. Category 2 hurricanes have winds of 96 to 110 miles per hour and a storm surge of 6 to 8 feet. Some trees are blown down, and there is major damage to mobile homes. There can also be damage to the roofs of buildings. A Category 3 hurricane has winds of 111 to 130 miles per hour with a storm surge of 9 to 12 feet. Large trees are blown down and mobile homes leveled. There is some structural damage to buildings. Category 4 hurricanes have winds of 131 to 155 miles per hour and a storm surge of 13 to 18 feet. There is extensive damage to roofs. There is also flooding inland as far as 6 miles. Major damage to the lower floors of buildings near the shore can be expected. Category 5 hurricanes, the highest rating on the scale, have winds of 155 miles per hour or greater, with a storm surge of 18 feet or more. There is extensive damage to roofs. Small buildings are overturned and blown away. There is major damage to the lower floors of all structures near the shoreline. On September 18, 1989, Hurricane Hugo blasted Puerto Rico with winds estimated at 130 to 160 miles per hour. Veteran storm chasers Jim Leonard and Mike Locka flew to Puerto Rico and videotaped the hurricane from the northeast part of the island. This is the first release ever of this unbelievable footage.
Yeah.
As the hurricane winds reach their peak, the photographers discovered they are trapped inside of the building where they have been videotaping the storm. The pressure caused by winds in excess of 100 miles per hour prevent doors from being open. Extremely heavy rainfall begins to flood the lower floor of the building. The eye of Hurricane Hugo passes over the photographer's position, and for a short while, all is calm again. The other side of the hurricane's eye wall soon brings more dangerous weather, including a massive storm surge. Hurricane Hugo went on to hit the South Carolina coast and has become one of the most expensive hurricanes to date, causing over an estimated $10 billion in damage. Here are some hurricane safety tips recommended by the National Weather Service. People who live in hurricane-prone areas should always be alert to the possibility of tropical storms and hurricanes. It is also a good idea to know the probability of flooding in your area. Make a hurricane safety kit. Flashlights, batteries, a portable radio, a first aid kit, and fresh water are important items. Prepare a family evacuation plan. Learn how to safely turn off utilities. Keep important documents such as insurance papers in a safe deposit box or waterproof file. A hurricane watch means that a hurricane is possible in your area. People living in isolated coastal areas should pay extra attention to watches, as evacuations may require additional time. If a watch is issued, stay tuned to your local National Weather Service radio broadcast, television, or radio for updated information. Board up windows if necessary. Bring in items which could blow around, such as trash cans, bicycles, and lawn furniture. Fill your car's gas tank. A hurricane warning means that a hurricane is approaching your area. Remember that a hurricane is a very large, intense storm, and a direct hit is not required for your area to receive severe weather or flooding. Hurricanes can change direction before landfall. If a warning is issued, evacuate immediately if required. If you are not required to evacuate, but still anticipate storm force conditions, stay away from windows and remain indoors. Remember that hurricanes can and do often spawn tornadoes as they move inland. Follow tornado safety rules. As we have seen in the Hurricane Hugo footage, the eye of a hurricane can often be very calm. Be alert to the possibility of additional severe weather as the other side of the hurricane passes. Avoid fallen power lines and broken gas lines. Avoid lighting candles for light. Wear sturdy shoes and be extra cautious of damaged areas and overhanging debris. Remain on the watch for flooding. Most people have never experienced a major hurricane and have no idea of the overwhelming power of water and wind. Many hurricane forecasters see this as a major problem, as most people living in hurricane-prone areas do not appreciate the awesome power of a major hurricane. On August 17th of 1969, 24 people decided to ride out Hurricane Camille in a Mississippi apartment complex. Half of them planned a hurricane party, which was popular in the 1950s and 60s. Despite urgent warnings by forecasters who labeled Camille as an extremely dangerous storm, the people still remained in the apartment complex. Hurricane Camille blasted the coast with winds of over 150 miles per hour and produced a storm surge of over 19 feet. The apartment complex was leveled, and of the 24 people, only one survived. Although tornadoes may be a thunderstorm's most feared offspring, lightning is the storm's greatest danger. From 1959 to 1984, over 2,574 people have lost their lives, and over 6,000 have been injured by lightning. Each year, lightning kills an average of 150 to 200 people. It is estimated that at any given moment, nearly 2,000 thunderstorms are in progress over the Earth's surface, and lightning strikes the Earth 100 times each second. There are 45,000 thunderstorms daily and 16 million annually around the world.
This is Mission Control. Houston, we're receiving downlink from the payload bay cameras of Atlantis as it crosses over the continent of Australia. The occasional flashes that are seen on the Earth are lightning storms that are covering that continent.
The following photographs were taken in Arizona during the monsoon months of July through August. The exact scientific explanation of lightning is still debatable, but most scientists do agree on these basic principles. Because of complex chemical and physical reactions which are not completely understood, storm clouds develop a positive charge at the top of the cloud and a negative charge at the bottom. The area on the ground below the cloud develops a positive charge and follows the cloud like a shadow. Next, an electrical potential or buildup develops between the cloud and the ground. When this potential reaches a critical level, a flow of electrons rushes down towards the ground in a series of steps, or what's known as step leaders. As the tip of this invisible leader approaches the ground, the positive charge rushes upward from the ground to meet the negatively charged leader from the cloud. After these leaders meet, a large flow of electrons flow to the ground, and a larger, more luminous return stroke rushes upwards toward the cloud, following the established pathway. The return stroke travels from the ground up to the cloud in about 1/10,000th of a second. Lightning appears to flicker because what we actually see is a series of rapid return strokes. We hear thunder when air near the lightning channel is superheated and expands rapidly, creating sound waves. The lightning stroke can heat the air through which it travels to temperatures of over 50,000 degrees Fahrenheit, or 5 times hotter than the surface of the sun. These lightning safety tips are recommended by the National Weather Service. Remember that lightning is a thunderstorm's greatest killer. It does not take a large threatening thunderstorm to produce a deadly lightning bolt. Any large cumulus cloud is capable of producing lightning. A lightning bolt can strike several miles away from the parent thunderstorm. Lightning can also strike from under the storm's anvil cloud. If you are outdoors and a thunderstorm approaches, seek shelter. If you are caught in the open without any chance of finding shelter, seek the lowest area of the terrain and crouch down. Do not seek shelter under isolated or large trees. Groups of people should spread apart. Remove all metal objects, such as watches and coins. Research has shown that the difference between a person living and dying when a group of people are hit by lightning can be a coin in a pocket or a watch, which attracted the lightning. Keep away from metal objects, such as golf clubs, water faucets, screen doors, water pipes, and metal fences. If you are swimming or boating, get out of the water and seek shelter. Golfers should be extra careful of lightning, as golf clubs and metal cleats are very good electrical conductors. Children playing on open fields should also seek shelter, as playgrounds are especially dangerous. Avoid using the telephone during thunderstorms, except for emergencies. Lightning can travel through telephone lines. If you should feel your skin tingle or your hair stand on end, the electrical potential between the cloud and ground may be building to a dangerous level, and a lightning strike may be about to occur. Crouch down and bend over your knees right away. Do not lay flat, and cover your eyes and ears if possible. People who are struck by lightning do not carry any electrical charge and can be handled safely. Many people who have been struck by lightning can be revived by CPR. For this and many other reasons, it is a good idea to learn basic CPR.
Very large tornado, unfortunately, appears to be going through a populated area now.
Although thunderstorms can produce a variety of dangerous severe weather, tornadoes are probably the most feared offspring. Unlike hurricanes, which can be carefully tracked by satellites, tornadoes often hit without any warning. With winds of over 300 miles per hour, they can leave a path of incredible destruction and tragedy. Each year, an average of 1,000 tornadoes are reported. Tornadoes can happen at any time, day or night, but over 80% of tornadoes occur between noon and midnight. Tornadoes are rated by a system known as the F scale, developed by Dr. Ted Fujita, a scientist who has spent many years researching tornadoes and their associated damage. An F0 tornado has winds of 40 to 72 miles per hour and damage is light. An F1 tornado has winds of 73 to 112 miles per hour and damage is moderate. Trees are snapped and windows are broken. An F2 tornado has winds of 113 to 157 miles per hour. The damage from an F2 tornado is considerable. Large trees are uprooted and weak structures are destroyed. An F3 tornado has winds of 158 to 206 miles per hour and produces severe damage. Trees are leveled, cars are overturned, and some walls may be removed from buildings. An F4 tornado has winds of 207 to 260 miles per hour, and damage is devastating. Frame houses are destroyed, and steel reinforced structures are damaged. The highest tornado rating is F5. This unbelievably powerful tornado has winds of 261 to 318 miles per hour and produces incredible damage. Often, an F5 tornado reduces a well-constructed building to a slab of concrete. This amazing tornado footage was videotaped by Davida Lenzer on June 2, 1990. The tornado was located about 10 miles southeast of Fairfield, Illinois.
Hello?
Here's Sam and Cindy.
No, we ain't got no electricity. You see the tornado coming?
Is that them?
You see the tornado coming?
Mother?
No, in the air. In the air, outdoors. Look out the window.
Is that Merlin?
Yeah.
Okay, tell him and Jamie better watch it.
You better watch, and you have to go down the basement. We're gonna go down the basement in a minute.
Tell him I'm taping it.
Get down the breezeway, guys.
We're watching it, Sam.
Down there.
Okay, Mother, hang up.
I gotta hang up.
Mother, hang up. Tell Merlin to hang up.
Oh, you guys down here with us.
Get down in the breezeway.
Huh?
Go on downstairs, Mother.
Who you calling?
Tricia. Go on downstairs, Mother.
Ain't got no flashlight. You guys got a flashlight?
Watch out to the west, Patricia. There's a tornado over here about Mother's.
Go on.
Oh, and Oklahoma.
Isn't that funny looking?
I bet it's gonna miss the house here, but then the little one's spawning off of it, you see there.
Uh-huh. Yeah, but see how it's so calm?
I tell you what, that's been on the ground a long time.
Yeah. My God.
Okay. It's going by now.
It's not safe to come up.
You ought to see it. Come on up now. Ready? Yeah. Come and look right quick. Right back here. Go back over here. See it? See it, huh? You want to see it, Mother?
This dramatic footage was taken by Earl Evans during the April 26, 1991 tornado outbreak in Kansas and Oklahoma. The F4 tornado is seen near the Teradyne Country Club in Wichita. The tornado destroyed over 500 homes in the area. And this is the same tornado which hit a trailer park in Andover, Kansas, killing 15 people.
Yeah.
Tornadoes are most numerous during the spring months of April, May, and June, but they can occur any time during the year. It is important to know your area well, as tornado watches and warning information is issued by county. Have a family plan in the event of a tornado warning. All family members should know the location of a shelter if a warning is issued. Remember that a tornado watch means that tornadoes are possible in and around the watch area. Monitor your National Weather Service broadcast, television, or radio for updated information. Many radio and television stations in tornado-prone areas now have live and continuous coverage during periods of severe weather. A tornado warning means that an actual tornado has been confirmed by spotters and/or by radar. You should take shelter immediately. Stay away from windows. Do not attempt to open doors or windows. The old advice to open windows to allow the pressure to escape during a tornado is false. Go to the basement or storm shelter. If a basement or shelter is not available, go to the lowest floor of the building and into a bathroom, closet, or interior hallway in the center of the building. Protect yourself under something sturdy and protect your head. A good last resort emergency shelter can be made by seeking shelter in a bathtub and placing a mattress over your body. Do not stay in a mobile home during a tornado warning. And never try to outrun a tornado in a car. Many people have been seriously injured or killed while attempting to outrun a tornado. If you are trapped outdoors and cannot find shelter, find a ditch or depression in the earth and cover your head. Caution should be given to dry riverbeds and ditches for flash flooding. At night, the only sign of a tornado may be a loud roaring sound, often described as sounding like a jet aircraft or freight train. Tornadoes at night may also be illuminated by lightning. After a tornado has passed, be cautious of downed power lines, broken gas lines, and overhanging debris. For additional information on tornado safety, contact your local National Weather Service office.
It is emphasized that this is a potentially dangerous weather situation for much of Oklahoma. Extreme instability and the expected winds aloft indicate the potential for a significant severe weather outbreak later today, including the possibility of very destructive tornadoes.
This spotter's guide is intended as an introduction to the basic spotting principles of spring-type severe storms. This guide is not intended to qualify persons as official spotters. A certified spotter should have many hours of training and actual storm observations under the guidance of an experienced spotter. Persons interested in becoming official Weather Service or Skywarn spotters should contact their local National Weather Service office. Most spring severe storm days are marked by a number of combined atmospheric conditions which increase instability and the chances of severe weather. High surface dew points, wind shear from the ground upward, surface heating, strong southern winds, and a triggering mechanism such as a low-pressure trough or wave are important elements in the probability of severe weather. Severe weather forecasting is a very delicate procedure with a number of ever-changing variables which can enhance or decrease the chances of severe weather. Persons who wish to become efficient weather spotters are encouraged to develop a thorough knowledge of basic severe weather meteorology. The most common type of thunderstorm is the multi-cell storm. These storms are comprised of a number of storm cells which grow and merge into the main body of the storm. Multi-cell storms can produce all forms of severe weather, including moderate tornadoes. It is also important to note that multi-cell storms can develop into more powerful supercell type storms. Here are some examples of multi-cell storms and their features. Massive atmospheric instability often results in squall line storms, which are a long line of thunderstorms which can reach for hundreds of miles. Squall lines are most common in front of cold fronts or when the temperatures in the upper atmosphere allow massive and uncontrolled storm development. The most common location for severe weather development along squall lines is towards the southern end, where new growth can quickly reach severe limits. Although squall line storms can produce severe weather, they are generally not as severe as individual thunderstorms and are usually very poor tornado producers. The most common dangers from squall line storms are straight line winds and heavy rain. Supercell storms have the greatest potential for severe weather, including very large and damaging tornadoes. Supercells can produce violent weather for extended periods of time, and they exist only in the best of atmospheric conditions, especially those with supportive upper wind shear. Supercells are divided into 3 separate types. The first type of supercell storm is the LP, or low precipitation. This type of supercell is most common along the boundary separating the moist air and the dry air, also known as the dry line. LP supercells can look very impressive because of their spiraling cloud bands and general lack of heavy rainfall, which give the viewer excellent visibility. Spotter reports of LP storms are very important because LPs are often difficult to spot on radar because of the low radar reflectivity due to the lack of rain and hail. The HP, or high precipitation supercell, is a storm which has a very large area of precipitation north of the main updraft. HP supercells may also have a second area of heavy precipitation falling through the updraft area, which can make it difficult to spot tornadoes. The last type of supercell is the classic. The classic supercell can be identified by a sustained flanking line of towering cumulus which feed into or around the main updraft. The updraft area is generally rain-free, with the main area of precipitation north of the updraft. Like most supercells, marked rotation can be observed in the massive area of cumulus clouds located above the updraft area. It is important to note that many supercells are hybrid variations of these 3 types.
613.4, very strong winds, rain and hail, moving very rapidly eastward just ahead of us. Watch for possible debris. We're entering a high danger zone. You might, if the wind gets too much to battle, you might slow it down. Estimated wind speed 50 to 60 knots. Rain or hail curtains wrapping extremely rapidly right at 11:30, right ahead of us, and very dark ahead. And maybe we'll have better visibility in just a second. We're driving into a strong mesocyclone. Okay, now be real careful, Neil. Slow it down. This would be where we drive right into the tornado, so be very, very careful.
CG.
Rapid circulation right overhead. Slow down, Neil. Stop. Rapid circulation. About 1/2. Debris! Debris! Tornado! Passing right in front of us.
I got it on video.
The understanding of severe storms begins with observations of their behavior. Numerical models of thunderstorms can be used to complement this understanding. These models consist of mathematical equations which can be solved on a supercomputer. Wind, temperature, pressure, and other values are calculated every few seconds for several 100,000 locations in the area of the storm's development. The numerical storm grows in wind and temperature conditions observed prior to an actual severe thunderstorm. A storm grows quickly from a small cumulus cloud as warm air rises in an updraft. This upwardly moving air reaches a height where it can no longer rise without restraint. It then spreads out, creating a growing anvil. The strong updraft forces the cloud into a dome shape above the anvil. A flanking line of low clouds forms along the gust front. Along this line, storm-generated cold air from the sinking downdraft meets the warm, moist air feeding the updraft. Within the numerical storm, small water and ice particles, shown in gold, can be set apart from the large ones, shown in blue. This blue, or reflectivity region, is what radar typically sees. A vault-like structure is apparent in the updraft region, signifying that large particles have not had time to grow there. The V-notch developing at upper levels indicates that large particles are being swept away from the updraft by strong winds. Radar reflectivity is often displayed within a nearly horizontal slice through a storm. The reddish area in this slice is the region of highest reflectivity. The slider on the color bar points out the maximum concentration of large water particles. Rapid growth is followed by smaller variations as the storm continues to evolve. A characteristic hook shape develops on the south side of the storm. The updraft vault is just to the east of this hook. Airflow relative to the movement of developing storm is represented by weightless tracer particles. Tracers that rise inside the numerical storm are introduced near the ground to the southeast of the storm. Tracers are released again in the same region as the storm matures. The airflow has a sheet-like appearance that moves and twists through the storm. Air moving several kilometers above the ground approaches the developing storm from the west and eventually descends. Evaporation of water near the ground cools this descending air, creating the gust front. As the storm matures, air moving several kilometers above the ground forms a twisting sheet as it approaches the storm from the south. It then sinks while moving around air which is rushing rapidly upward. Weightless particles released near the ground at regular intervals are colored orange when rising and blue when sinking. Yellow streamers clarify paths taken by individual particles. Initially, all air in and around the storm rises upward. Then, as large precipitation particles form, some of this air begins to fall to the north of the main updraft. This separation of updraft and downdraft is crucial for the continued development of a severe storm. Rotation of air in and around the storm is an important factor in its behavior. A ribbon's rate of twist indicates the amount of local rotation. This is termed streamwise vorticity. The twisting of these ribbons is predominantly clockwise when facing the direction of the ribbon's movement. Substantial rotational growth is evident as the ribbons begin to rise in the updraft or enter the downdraft. Such flow is an important factor in prolonging an individual thunderstorm's life. All of the previous techniques are combined to show the complexity of the storm and correlation of the different features. A cutaway of the cloud reveals the relationship of the interior structure to the rising air within the storm. As computer power increases, so will the understanding of storms, including smaller scale features such as tornadoes. With the use of visualization techniques, the scientist is able to make sense of the growing billions of numbers produced by a single numerical simulation. Numerical models, supercomputers, and visualization will continue to be important tools for studying the behavior of severe storms.
As you have just seen on the supercomputer storm model, the average severe storm begins as a solid towering cumulus cloud. Although many such cloud formations may form during the early afternoon, a few will usually begin to dominate the atmosphere and form a cumulonimbus cloud or a thunderstorm. Once a thunderstorm begins its transformation from towering cumulus into cumulonimbus, a spotter must begin to look for the characteristics of a severe thunderstorm. Severe thunderstorms are defined by the National Weather Service as producing one or more of the following elements. 1. Tornadoes. 2. Winds of 58 miles per hour or greater, or simply damaging winds. And 3. Hailstones 3/4 of an inch in diameter or greater. Often, the National Weather Service will issue a severe thunderstorm warning based on radar observations only, but actual spotter reports are critical in determining the exact status of the storm. Flash flooding, intense or constant lightning, microburst or straight line winds, and dust storms should also be considered as dangerous storm features and reported as required by spotter groups. Although spotters report any type of dangerous weather, they are always on the lookout for any sign of tornadic development. The word tornado should only be used by spotters when a funnel cloud actually touches the ground by visual contact or when dust swirls or debris is seen directly under the funnel. All funnel clouds should be immediately reported, as the majority of tornadoes do begin as funnel clouds. The first sign of possible tornadic development may be a wall cloud or an area of rotation, usually located at the base of the updraft area. A wall cloud can be a ragged or rounded protruding structure. It may rotate violently or show little or no movement. Although wall clouds are the most likely area for tornadic circulation, Tornadoes and funnel clouds can and do develop suddenly without a noticeable wall cloud structure. Here are some examples of wall clouds and their associated phenomena. Spotters should note that tornadoes can develop from any updraft or nearby area without warning. Tornadoes can also be embedded in the rain curtains or hail shafts. Various clouds, known as accessory or scud clouds, may also be found around the wall cloud or updraft area. Although these clouds may signal certain warning signs to experienced spotters, these clouds do not suggest imminent tornadic development. It is important to note that not every wall cloud will produce a tornado, as roughly less than 50% do. Tornadoes and funnel clouds can take on many shapes, sizes, and colors. Here are some examples of funnel clouds and tornadoes. In addition to the tornadic features associated with thunderstorms, spotters should also watch out for the other severe weather mentioned in this guide, including large hail and damaging winds. Depending on the individual operating and reporting procedure of spotter groups, certain phenomena may or may not be required to be reported by spotting groups. Many spotters will report surface wind conditions, as various inflow or outflow winds can help determine storm development. There are a number of thunderstorm structures which are often mistakenly reported as tornadic features. Some of these are heavy rain shafts. In fact, there were several reports of a monster-sized tornado on the ground after lightning illuminated this large dark rain shaft. Gust fronts and shelf clouds can be the most menacing appearing structures of a thunderstorm. They are caused when cold air falls from the top of the storm and condenses as it comes into contact with the warmer air at the surface and spreads out in front of the storm. The underside of a gust front can look black, and clouds may be twisting, rolling, or exhibiting severe turbulence. This motion should not be confused with the updraft area of the storm. For this reason and others, it is very important that spotters learn the structures and general movement of thunderstorms and know where they are in relationship to these structures at all times. Although gust fronts do not pose any serious threat, they can produce small vortices known as gustnadoes, which can be strong enough to cause minor structural damage. Dust caused by outflow or inflow winds can often be mistaken for tornadic dust swirls. In the southwestern United States, dust devils are often reported as tornadoes. Dust devils originate from the ground up and usually occur in advance of the storm as strong outflow winds and high surface temperatures assist in thermal rotation. Roll clouds can be found in front of the gust front. These clouds are not attached to the actual storm structure and do not pose a threat. Mammatus clouds are often seen on the underside of the storm's anvil. These bulbous appearing clouds signal extreme turbulence. Tornadoes do not develop from these clouds. Smoke from a ground source which rises into the base of a thunderstorm can form the perfect tornado mirage and fool even the most experienced spotter, especially when viewed from a distance. Most spotters will position themselves in a strategic location in relation to the storm, which offers both a visual and safe perspective. Experienced spotters will use caution when placing themselves near storms to avoid lightning and other possible hazards. Storms can move quickly, expand rapidly, and even change course within minutes.
The leading edge of the thunderstorm right now is just moving towards the southwest. This ominous looking cloud in front of me I do not believe is a wall cloud, but rather some scud coming out of the leading edge of the storm.
Anyone who wishes to become involved in storm spotting must be willing to accept the responsibility that lives depend on accurate and timely reporting. The public depends on the reliability of severe weather warnings, and every spotter has the responsibility to accurately report severe weather events. If too many inaccurate reports or warnings are issued, over time the public may lose faith in the system. Apathy towards severe weather can and has been fatal. Never spot or observe storms by yourself. A second person can be a lifesaver if someone is injured, and spotting with a more experienced person can give you valuable training. Learn basic first aid and CPR. Remember that lightning is the storm's greatest danger, and the majority of lightning strike victims can be revived with CPR. Obey all speed limits and traffic laws, and watch out for other vehicles. There is usually an increased amount of traffic around big storms, including emergency vehicles. Establish adequate and dependable communications. Most spotter groups utilize ham radios, cellular phones, or citizen band units. Always use the proper radio etiquette and only report confirmed events. Always be on the guard yourself for lightning, large hail, flash flooding, and microbursts, as well as tornadic activity. And know your subject well. Learn as much as possible about severe weather, storm development, and related structures. The National Weather Service's storm safety guidelines are an excellent source for additional storm safety information.